The energy stores story imagines a pathway called electrical working that connects the chemical store of the battery with a thermal store of the surroundings. It accounts for why the chemical store of the battery goes down and the thermal store of the surroundings goes up. The stores and pathways model is good for explaining ideas about the conservation of energy, like how bright is my bulb, or how long will my battery last? If the pathway is broad, then the chemical store of the battery runs down quickly and the bulb is bright. If the pathway is narrow, then the chemical store of the battery runs down slowly and the bulb is dim. But this pathway is just a story. It doesn't go along the wire or anything like that, and it's not meant to be the current itself. The pathway has the same reality as a meme. The meme is the idea. It doesn't depend on who sent it, or who received it, or how it travelled around the internet. If we want to get a picture of what voltage means, then it helps if we imagine that each coulomb of charge carries energy along the wires from the battery to the bulb. And that's what this red stuff represents, energy. We're not saying that this is what really happens, but it helps us connect ideas like voltage, current, and brightness. We imagine that the charges carry energy from the battery to the bulb, and that as the bulb shines and gets hot, that energy spreads out into the environment. Notice how the energy never disappears, it just gets spread thinner and thinner. We say that the voltage is how much energy each coulomb of charge has. In other words, how much red stuff each black dot has. So this part here, this part of the circuit, has a high voltage. And then as you go through the filament of the bulb, the energy per coulomb goes down, so the voltage goes down. And on this side of the bulb, you can see that the black dots have no red stuff, no energy. And so we say the voltage here is 0. So if we increase the power supply, like this, increase the voltage of the power supply, then you can see that each coulomb of charge gets more and more energy, but the pattern's still the same. The voltage is high here, it drops through the filament of the bulb and ends up as 0 at the other side. And that doesn't matter where you set the battery voltage, and obviously you set the battery voltage by changing the number of batteries. So the pattern always stays the same. Lots of energy per charge leaving the battery, in other words, high voltage on this side of the bulb, and then the voltage decreases as it goes through the bulb, and 0 on the other side.